following me always. Please don't forget to subscribe, don't forget to comment, don't forget to like, don't forget to share for other people to get it. So let us briefly look at these few questions, simple questions of probability. They say prove that for any three events A and B, probability of A given B plus probability of A prime given B is equal to 1. And then A and B are two independent events, show that A and B prime are also independent. Let us start with 1. We have that I am going to take the left hand side because the right hand side is equal to 1. We are proving. So I'm going to take this side and see whether it will give me answer 1. If it gives me answer 1, then we will have proved that it is correct. So we shall have that probability of A given B plus probability of A prime given B. This is our left hand side. Sorry, this left hand side. So we will have this is equal to, I'll have probability of A given B. This probability of A given B is equal to probability of A intersecting B out of the probability of B itself. And probability of A prime given B is equal to probability of A prime intersecting B out of the probability of B. So I replace them back. So my left hand side would be equal to probability of A intersecting B out of probability of B, then plus probability of A prime intersecting B out of probability of B. Like that. So since we have the same denominator, we can combine. So the left hand side actually becomes probability of A intersecting B plus probability of A complementing intersecting B out of the probability of B. That's what we have. So because they have said these events, just any three events, they have not told us whether they are independent or maybe they are mutually exclusive. So we shall write straight to our contingency table and see how probability of A intersecting B and A prime intersecting B are actually connected or linked. So from contingency table, we have this is now this is going to be A complement, and I'll have this is B complement. This is A intersecting B. This one becomes probability of A complement intersecting B. This is the probability of A intersecting B complement. And this is the probability of A complement intersecting B what? Complement. So you see that this is A intersecting B and this is A complement intersecting B. So meaning I have this. So that implies that it is the probability of B. Probability of B is equal to probability of A intersecting B plus probability of A complement intersecting B. That's what we have. So probability of A intersecting B plus probability of A complement intersecting B is equal to probability of B. See how easy it is. It's coming so fast. So therefore, left hand side is equal to probability of A intersecting B plus probability of A complement intersecting B out of probability of B, which is equal to probability of B out of probability of B, which is, this is probability of B out of probability of B. So therefore, the left hand side equal to 1. Hence, proved. We have actually proved that one out. Question 1 has come out. Let's go to question 2. Question 2 is telling us that A and B are independent, are two independent events. Show that A and B prime are also independent. So you have to know that if A and B are independent, then probability of A intersecting B. For independence, we have that probability of A intersecting B becomes probability of A times probability of what? Of B. That is for independent events. And if A and B are independent, then we are supposed to show that A and B prime are also independent. So let me first see how we can get the probability of from our contingency table. I'm not going to draw another contingency table. I'm going to use this same one. So from the contingency table, I want to see what is connecting A and B and A intersecting B. These two. So I'll see that from contingency table, contingency, we have that probability of A itself is combining these two. It is equal to probability of A intersecting B plus probability of A, yes, intersecting B prime. It is B which is supposed to be a prime. So in this case, let's make probability, and what we want to know is A and B independent. If A and B prime are independent, then we have to show that probability of A intersecting B prime is equal to probability of A times probability of B prime. So therefore, we see that probability of A intersecting B prime is equal to probability of A minus probability of A intersecting B. But already we said A and B are independent, and so since they are independent, so we have this probability of A times probability of B being equal to probability of A intersecting B. So we replace. So we'll have probability of A intersecting B prime is going to be probability of A minus. This is probability of A times probability of B. So you see, I am going to factorize out probability of A. It is a common factor. So probability of A intersecting B prime is equal to probability of A. And then inside I remain with 1 minus probability of B. But we are very sure that probability of 1 minus probability of B is a probability of B prime. But we know that 1 minus probability of B is equal to probability of B complement. From the fact that probability of B plus probability of B prime is equal to 1. So this one comes out. So therefore, probability of A intersecting B prime becomes probability of A times this one is probability of B prime. So it is clear, it tells us that if A and B are independent, then A and B prime are independent. Hence, if A and B are independent, then A and B prime are also independent. Thank you very much.